Hello and welcome back to Dr. Logic Awkwardly Does Logic and proves you more theorems. This particular theorem is one that we're going to give a name for. We're going to call it modal interchange. And it's because it talks about the relationship between possibility and necessity. And it ends up being very useful in the way that quantifier interchange was in predicate logic. So there's kind of two versions of it. We'll prove one and the other will be a corollary. The first is that in system K, and therefore in any of the systems we are looking at, necessary P is going to be equivalent to not possibly not P. Now, start off by recognizing that P is equivalent to its double negation. This is just propositional reasoning. We can then do substitution on this to get necessarily P being equivalent to not necessarily P. So this is uniform substitution, necessarily P for P on line 1. Now, double negation via the substitution of equivalences rule allows us to stick in two negations between the box and the P as well. So we've got 2 before the box, 2 after, double negation on line 2. And then we've got our not box, not string, which is just definitionally equivalent with the diamond operator, meaning that we can, by definition of possibility, change this from necessarily P to not possibly not P, as we wanted. Then we have the other version of the modal interchange, which can be derived as a corollary, is that possibly P is equivalent to not box, not P. And this comes just from the way that we have defined the relationship between possibility and necessity. So this theorem, because it's our 5th one, we call it K5, but more often we are going to refer to it as modal interchange, because it's an equivalence, along with the substitution of equivalences rules, means that whenever we have a box, we can always replace it with not possibly not. And anytime that we have a diamond, we can always replace it with not necessarily not. So this is a super useful theorem, very quick and easy to prove, and we will use it all the time. Because one of the general kind of proof methods that we will see quite a bit is you take a theorem that you've already proven and then do some contraposition, do some De Morgans so that your ands become ors and vice versa, stick in a substitution instance involving some negation, and then change all your boxes for diamonds. So basically every theorem that we prove has, in a sense, a dual theorem, which will interchange diamonds and boxes and interchange conjunction and disjunction and swap the antecedent and consequent. So we'll start seeing examples of this sort of theorem soon. And once you kind of see the method of proving this, you'll be able to use this over and over and over again. So join me next time for yet more theorems. We've got a whole bunch of theorems to prove because this provides us with a foundation for going forward and investigating logical systems that are somewhat more interesting than K. But they're all built on K, so we got to get started somewhere. Take care and see you later. Cheers.